in terms of climate change is our last big topic that we're going to discuss in class. No, I don't think I'm going to be really. I'll think that. So what's possible is that? So we are going to talk about climate change here. Let's not. As our last topic in class. I'm sure that. Oh my gosh! Here, how about you talk? We'll see if we can fix it as a class. All right. Today we're going to be very focused on what is climate change and some evidence of current climate change. And our first picture here, which is of the Sperry Glacier in Glacier National Park, is an example of climate change. It's experienced a vast loss of the surface land-bound ice. And the recession of this glacier over 95 years, look at the top picture in 1913, and then this extent in 2008, is an example of that loss of glaciers. And the loss of glaciers is one of the things that contributes to sea level rise. And it also affects land albedo and reflectivity of the Earth's surface. It affects how much warmth and radiation the surface of the Earth receives. It affects local climate and weather patterns to a great extent. And it's one of these indicators that climate is changing. We're no longer building up ice. We're no longer maintaining ice. We're actually losing ice. So it is a sign of a warming climate. It's not actually working.
Did you put the battery in right?
I think
Yes, Eagle Scout.
Oh my God. Okay, speaking of Eagle Scouts, last Saturday we went out to Stone Lake State Park, and there were 8 of us or so from class that participated in the winter cleanup. We had a really good time. Willow and Grace went with me, and I almost lost Jess and killed us on the side of the highway numerous times. It was awesome. But we collected a lot of trash. This is the last bag of trash that we deposited on the side of the road. You can see the ladies there. Homework 4, if you participated in Saturday,
On a merit badge.
is due next Tuesday, as is homework 6 for everyone. Okay, homework 6 is writing a proposal of what you would do next as a service learning project in association with any one of the organizations. Any one of the organizations that we work with. You're welcome to work as a group. If you have 2, maximum 3 people that you want to write your proposal with, or if you want this to be an individual project, that's fine, okay? I'm asking for an online or hard copy submission next Tuesday of your proposal. Make sure you look at the grading rubric, okay? If you hit what's on the grading rubric, you're gonna get the points for the proposal, okay? If you leave something off, then you're gonna get a 0 in that category, okay? So make sure you follow the rubric. That'll make sure you have all the important parts in your proposal. The last thing I wanna mention in regards to service learning is that after the end of the semester, just at the start of summer semester, we have the day of service that UC participates in. That's UC Serves Day. This year it's May 17th. Last year I worked at the elementary school where my kids are, and we worked on their sensory garden that they have for kids with special needs. So we cleaned it all up and put new mulch down, took all the weeds out, something that the teachers, of course, can't do on a weekly basis. And so there are lots and lots of opportunities out there. There's probably over 50 different organizations that have service learning opportunities on May 17th. And you can find one that's close to you. You can find one that interests you. I encourage you to participate. Okay, and you get a t-shirt. And you usually get free lunch. Okay. Any questions about homework or class logistics? Yes, Elena.
Do you have exam times available to us?
Yes, I will post it. You can definitely look online at what the exam schedule is for us. And I want to say that we are testing Tuesday morning of exam week. Yeah, I think it's 9:45. We're going to start earlier than class time. So keep that in mind.
It's not the 7:30.
Yeah, at least about the 7:30 time slot. But I'm pretty sure it's the morning. Okay. All right, our learning objectives today, we're going to talk about climate change and weather and climate in there too. So let's just talk about what climate change is. Then we're going to talk about the causes of climate change. What are the different factors, both natural and anthropogenic or human related, that can induce climate change? And then we want to start looking at the evidence that climate change is actually happening today. I always kind of start the climate change lectures with a understanding that if climate change that we're experiencing today is actually caused by aliens out in the rings of Saturn that are beaming something at us that's doing it, and then they suddenly appear and say they're doing it, I'll be the first one that's like, I was wrong, okay? It was not greenhouse gases, it was the aliens out in Saturn, okay? But right now, it does, okay? And so it can be a lot of pushback on that understanding that the climate change that we're experiencing, the rate and magnitude at which it's occurring is different from what's happened in the past, that the causes of it are actually anthropogenic and not of these variety of natural causes that do that. I hope to share with you in the next several classes the information that has convinced me that it is us, that it's related to greenhouse gas concentration changes. Yeah.
Have they done studies, like enclosed, like an area, put a light bulb, one of the heating light bulbs on there, and add greenhouse gas to see if it makes it warmer?
Yes, and it does. And I think that those types of simple experiments, which I mean you do in a literal greenhouse, are some of the best explanations that yes, this particular phenomenon does change climate, and that's the one thing that's changing today at the same time frame and magnitude of the climate change that we're experiencing. And so we cannot, and I think this is where there's a ton of pushback sometimes about the cause of climate change, which then means resistance of that climate change is happening and that we should deal with it. Is that we can't absolutely for certain say it is greenhouse gas concentrations that are causing this. There's a very, very explicit correlation between the two, but remember, correlation is not always causation, but sometimes it is. And in this case, I'm convinced that it is.
The other one, I'm sure you explain this at some point, but what is making this climate change compared to the other climate changes the Earth has gone through bad?
Good. The rate at which we are changing is much, much faster than climate change normally happens in the past. So the Earth has been warmer than this in the past. The Earth has had a higher greenhouse gas concentration than this in the past. But the time frame of that change is usually 50 to 100,000 years. Right now, it's happened in 200 years. That means that the rates of evolution for species are out of sync with the rate of change in their climate and habitat around them. And that means that they're not moving, migrating, they're not evolving at a rate to allow them to adapt and survive. And so that means that we're in for radical change when it comes to our habitats and our ecosystems because of the rate of change is so fast. Cool. All right, the scientists in the picture here are taking an ice core out of one of either the glaciers that are probably in Greenland or in Antarctica. Ice cores are one of the major ways that we can look at past climate, which gives us an idea of how our current climate and climate change compares to what has happened in the past. There are literally tens of thousands of years of climate data that are contained in ice cores. They give us data about precipitation levels. They give us data about greenhouse gas concentrations. So we have little bubbles of gas that are actually encapsulated and frozen inside the ice itself. And so that's how we get some of this information that we're going to be looking at. You're like, how do we know what CO2 levels were like 400,000 years ago? Well, we found these little trapped gas bubbles. We very carefully analyze them so as not to contaminate them with current atmospheric levels of these different gases. And you can look in the past and chart what temperature greenhouse gas concentrations are like from these types of data. Okay, tree rings give us similar information for the past, 40,000 years. We can look at a variety of seafloor sediments, again, looking at really interesting heavy isotope concentration variations in phytoplankton shells that have accumulated on the seafloor to tell us about climate. And so we actually have a pretty good reconstruction of what has happened in the past, and that lets us enhance our models of current climate change and understanding. Okay, so when we talk about climate change, we almost always think about the polar bears, right? And this is one of the iconic photos that represents climate change. I think that when we kind of first started thinking about this, there was this mom polar bear and this little polar bear cub, and they're like towering on this like ever shrinking little iceberg, right? And you're like, oh my God, climate change and polar bears. Why do we think about this scenario when we think of climate change?
It's really tangible representation.
Good. Like this is something that you have this charismatic megafauna response to. You have this like familial response of like, oh my gosh, she's not going to be able to raise her cubs. They look like they're in danger. You start to get that little kind of stressy response.
Well, you can also see, like, you can measure, it's much easier to see like, oh, clearly the ice is melted, it's getting warmer,
Good.
because you can see that versus
Right.
you may not be able to see some of the other environmental manifestations.
Good. This is another place where we can really see that sea ice has shrunk in the Arctic, and that is an indicator of changing climate, warmer surface temperatures, and it's warmer in the water, which inhibits the growth of sea ice in wintertime, because there'll be more melting ice. Okay. But again, like, what is the science here that makes polar bears the symbol for climate change? Talk about sea ice. Is there anything else?
Snow caps.
Okay, the snow cap and the snowball kind of goes on with sea ice.
How much they've adapted for the cold environment.
Excellent. So these are organisms that are extremely adapted to living in a very specific habitat. And these Arctic high elevation habitats are the ones that are most at risk from climate change, because there's nowhere else on Earth these organisms can migrate to. There's no place that's going to be as cold as they are now with climate change. Okay? There's no place for them to move. They're already at the limit of where their habitat can exist. Okay? Organisms that live in the tropical rainforest, they can migrate north and south to stay in their preferred temperature range. Polar bears and other Arctic organisms are stuck there. Yeah.
Screens in a bad position as well, or?
You know, if I was living in Greenland, I might be kind of pro climate change, because as their glacier and ice pack is receding, they're gaining arable land. They're in a position where organisms are going to be moving in that are favorable for humans to live in that particular location. I mean, we've got to like bring them to Greenland, right? It's an island. So if I was living on Greenland, I might be kind of pro climate change. So I'm getting a more suitable habitat for humans.
It'll sound like very much instead of.
Yeah, like it'll actually be green instead of white. That'd be cool too. That your name actually matched your country then.
So why do you-
I just remember opposite. Greenland is icy.
When the Vikings first went there, they were like, "Oh my gosh, a green land where we can establish our communities." But and then it was greener than where they came from.
God,
Right? Okay. Yeah.
Perspective.
If I was talking.
no wonder they were so angry and mean.
Yeah, exactly. What else about polar bears? So they're specific to their habitat, and their habitat is declining. The sea ice that is part of their habitat is melting. What else about the polar bears makes them a great poster child for climate change and their charismatic megafauna? Yeah, emotional appeal. And they're big, right? And the other thing, what I'm trying to get you to think about is that by making a top predator keystone species at the top of a food chain, the symbol for climate change, it means that any action we take to preserve the polar bear means that we'll preserve all the species in the food web that are needed to sustain the polar bear. Okay, like we don't care about diatoms, we don't care about the little Arctic fish that are running around on the seafloor. Like some of us kind of care about king crabs, right, that we harvest from the Arctic Ocean. But we all seem to kind of care about polar bears, even though they're rather violent and deadly.
Have you seen them after they eat?
Yeah,
They're
they're
funny.
There is an awesome video of a polar bear attacking like a vehicle that one of the videographers was on for Frozen Planet, and you're just like, I think that guy was dying. Okay, they're massive beasts, but protecting them means that we preserve the whole food chain that we don't know as much about, that we aren't as likely to have an emotional response about, that by preserving them, we get the whole ecosystem in the shebang. Okay, so they make a good poster child, but at the same time, climate change is not directly affecting the polar bear, it's affecting the polar bear's ecosystem, their habitat. And that then has indirect effects on the polar bear. And they have less sea ice for the most part, which is where they do their hunting during spring, summer, fall, in order to get seals. And without the seal portion of their diet, they tend to be smaller, they tend to be emaciated, they have much more difficulty raising their cubs successfully. So we're looking at here in the white coverage area here is the median ice edge, is the September 23rd, 2018 ice cover. That's the white part. So that's the minimum sea ice that we had in the Arctic this last summer. Usually happens there in late September when conditions are actually warmest in that part of the world. This is the time when there's the least sea ice that there is going to be each year. It's what we consider the minimum sea ice. It means that, this is the area that's covered by sea ice through the entire year that's really continually available for organisms to utilize the sea ice in this habitat, both humans and things like polar bears. Okay. The median line of where this extent of summer sea ice used to be from the period of 1981 to 2010 is that orange outline that you see around. Okay. Sea ice in the Arctic today is about 40% less than what it traditionally has been in our climate understanding, in our climate models, and our climate measurements. If we look at the decline of sea ice, you see that almost every single year in the Arctic, we're getting less and less sea ice that's produced come winter, which means that it retreats even farther back each summertime. The minimum sea ice extent in the Arctic happened in 2012, 2013. The last few years have been a little bit better than that, but it continues this downward trend line to the point that by 2050, we expect that at this minimum sea ice in the summer in the Arctic, we'll have open water at the North Pole. You could actually get on a boat and you could go from someplace in Canada all the way across the Arctic Ocean and land up in Russia. Okay. You have that northwest passage will be open again. Which is interesting from a trade perspective, from a globalization perspective, but it indicates a fundamental change in the operation of the Arctic ecosystem. It means that there won't be sea ice, which means that the normal incoming solar radiation that is reflected by the sea ice that prevents warming of the ocean won't be there. And the surface water will continue to absorb solar radiation. It will be even warmer than it has been in the past. Some of the greatest rates of change in terms of temperature that we see happen at the poles because of these very fundamental shifts in things like ocean currents, thermohaline circulation, and land albedo, ice production and formation, which affects the absolute amount of solar radiation that's received. And that's something I want you to keep in mind as we consider climate change, is that it's all about the sun. And it's all about how much of the sun's energy we receive as a planet, and then how much we retain. Okay, that determines what our temperature is. And as our temperature changes and fluctuates, precipitation and wind patterns change and fluctuate too. And those three things together build climate. Okay. All right. So in order to talk about climate, we have to make sure that we have the same understanding of what climate is. And so I usually start by mentioning what weather is, and then allowing climate and climate change to be a contrast to that. Okay. So weather is the short-term atmospheric conditions in a very localized region. Okay. We're talking about daily temperature, humidity changes, our precipitation events, and our severe weather that happens. That's weather. Okay. We can predict it about 7 to 10 days in advance now. Most websites and even the newspaper these days prints usually like a 2-week weather forecast. And you know that the next day's weather is pretty well set. We can have a lot of confidence in those weather predictions. But you know that the 7 to 10 to 14 day forecast, it can be a little variable which day it's actually going to rain, and the minimum and maximum temperature can fluctuate.
Grass with snow.
Yeah, like yesterday we had snow flurries at my house. But it wasn't as bad as my parents in Minnesota that got 10 inches of snow last Thursday from that bomb cyclone storm that we had. That's weather, okay? Those daily severe weather events, that's weather, okay? It builds into climate when we look at average conditions over a long period of time and over a bigger geographic region. Weather varies place to place, even though we might recognize that those places are in the same ecosystem, they're in the same biome, and have the same climate. So we may know that it can be variable weather, like we had snow flurries in Macon yesterday, maybe you just have them here in Claremont. Definitely last Friday morning here in Claremont, you guys had severe thunderstorms and tornado warnings, and I didn't have that in Macon. You may be really familiar, look across the map of the daily maximum temperatures in Ohio, and Cincinnati was warmer or cooler than Dayton. just 100 miles apart, definitely have the same climate, they can have different daily weather patterns. Okay. The contrast to that, of course, is climate. And when you look at climate, we're looking at atmospheric weather conditions that are averaged over 3 decades or longer. So we're talking about 30 years worth of temperature, precipitation, wind pattern, storm frequency and intensity data that's being averaged over 30 years or more in a big geographic region like the state of Ohio. In our region, we tend to think about our climate as Illinois, Indiana, Ohio, little bits of West Virginia and Pennsylvania. And you get a different climatic regime once you get over the Appalachian Mountains. The mountains themselves have a slightly different climate themselves because they have these big elevation changes. Okay. It's the same thing, atmospheric conditions, the same basic ideas, temperature, precipitation, wind patterns, storm frequency and intensity. But now we're talking about a much bigger scale. The averaging and the looking over a larger geographic scale tends to even out those daily variations in temperature and severe weather events and precipitation and say that in the month of April, we anticipate that in Ohio, we should get a certain number of inches of precipitation. Okay. And that's based on 30 years worth of data that we have about precipitation that normally happens in Ohio. You can definitely think about climate as this kind of like big sink, okay? We have precipitation that's pouring in at the top on daily events that happen, and we have water that's flowing out of these watersheds at the bottom. The average level of water in the sink is climate. The little ups and downs that happen because we have droughts that are short term, or we have actual severe weather events. Those are the little ripples, the waves, the peaks that happen, and the dips at the top of the tub. Okay. Weather determines what you're going to wear each day when you get up in the morning and you get dressed for the day. Climate determines what's in your wardrobe closet to choose from. Okay. When I lived in Florida, I'll be dead honest, I had lots of shorts and tank tops, but I didn't actually own a winter coat. Okay, because it was Florida and I never needed one. Okay. While I live in Ohio, that's drastically different. Okay, I have all these like 3/4 length capri pants, and I rarely wear shorts, and like I don't wear tank tops because the arm thing that's happening right now in my life.
Thank you, Mother.
But like I would sometimes, but I definitely have a winter jacket. I have long pants and I have snow boots. Yeah, you have everything because that's our climate. Our climate is very encompasses a big range of different temperatures and different weather events that are likely to happen here. We actually have good predictive ability for climate. We can predict it a season to a year in advance. Our U.S. Department of Agriculture puts out predictions about when we think the last frost is going to be in springtime, when the first frost will be in fall, how much precipitation we're going to get so farmers can plant the right types of crops for their region.
Yeah, I'm just curious, the Farmer's Almanac is almost always dead on,
Right.
like spooky dead
It's
on.
creepy.
Why is that?
Because of this. Because they're taking averages that encompass all the possible variations and they're saying, this is what's most likely to happen.
It's like the most prophetic little booklet.
Yeah,
you can
it's
get.
creepy. That Farmer's Almanac actually works, okay? We think like Benjamin Franklin and whoever wrote it, they were like, why would you write such a dumb thing? Like actually they were being very intelligent. They were trying to help our economy and agriculture. Get stuff together. Today, the Farmer's Almanac is put out by things like NOAA, the National Weather Service, and the USDA, because those are the people that are most likely to use it. That's my understanding of these things. Okay, climate change then is a shift that happens in these atmospheric conditions over decades or longer, okay? Climate change cannot be measured year to year. Climate change is measured decade to decade, or quarter century to versus quarter century. That means that we have to have long-term shifts in these variables in order for it to count as climate change. Okay. That means that even though climate change has been predicted since the 1950s that greenhouse gas concentrations were likely to cause a shift in climate, it's just now that we have the data that says, yeah, we were experiencing climate change and we continue to do so. We're all excited to see if it works, Andrew. All right.
The hour hands keep falling.
And we'll just let it die.
Yeah,
I got it working.
I'll make a, okay. All right, I'll put in a ticket. Finally. All right. One thing that I want you to recognize too and remember about climate change is that it's not just that the average temperature, precipitation pattern, wind pattern changes. It's that storm frequency and intensity can change too, and that the range can change as well. That we anticipate that climate change will cause extremes of temperature, will cause extremes of precipitation, will cause these extreme weather events. That's part and parcel of a shifting climate. And so again, it's not always about the averages, it's also about the range that we experience. Has the maximum changed? Has the minimum shifted as well? Everybody with me? Has anybody here, do you feel like you have anecdotal evidence of climate change from your life?
I think in the past 5 years, it's been like, and I think I noticed more as like a parent, like the ratio of my kids' snow days from year to year. And it's been really interesting over the past 5 years in winters to have 1 year, my youngest son needed a new winter coat, but I never had to buy him one because it was so mild. He wore a fleece. Mainly they didn't have any snow days. And then the next year was so extreme that they had a record amount of snow days.
Right.
And then back to, so I really can, I guess anecdotally relate to the extreme, the shifts of like, because you can't say, oh, winters are like this in Cincinnati anymore.
Right,
Because
no,
they're not as predictable. They can be super mild or they can be really frigid.
right, yeah,
Being as close to the river as my town is, I believe last year we had like decent bad flood.
right,
We usually don't. The last really bad flood that we had was in '97.
right. And those kind of what we used to consider 25-year, 50-year, 100-year floods, like they're happening more frequently than they should based upon our historical record. Willow?
I was just gonna say, when I was little, we played soccer and stuff, like the
Yeah.
weather, like depending on what year it was. So when I was like 7, we played like soccer games in snow in like October. Now
Yeah.
that's not.
That never
how it
happens,
is,
like you don't get that
yeah.
first snow
So
till
like
later.
now it's like pushed way
Yeah.
back, so like just the seasons have shifted a
Yeah.
lot.
Good, and that is true. We have good physical data that the seasons have actually shifted. Yeah.
I think one of the biggest things I've noticed is the winters are colder, the summers are hotter.
Yeah.
Like, when I was in high school, we didn't have a ton of, we had 1 year where we had a ton of snow days. But
Yeah.
after that, we didn't really have snow days. It was too cold
Mhm.
for kids to be outside to be on
Yeah.
the bus.
Oh, I know.
Which
It was
is
like,
That totally happened to my kids
Yeah.
this winter, right? We had that really cold
Mhm.
frigid temperature and they were like, it's like January this year, right? And they were like, oh, we're not even gonna ask the kids to be outside. And I'm like, as me, like, as a like
I
working
set my life.
parent, I'm like, dude, like, you're gonna tell, there's like a childcare factor, right? That's it. That's a sign of climate change. These really extreme events that seem out of the normal of our perception are signs that these minimums and maximums, these ranges are changing.
We don't have cold and spring anymore. It's just winter and summer.
Good. That's another thing that I feel that I've experienced is that it's cold, 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 and all of a sudden it's hot, right? Like that's happening this week, right? Like snow flurries yesterday, today it's gonna be 80 degrees. Okay, well 75, 80 is a slight exaggeration. That again, that big shift, that loss of, in our region, what we would consider spring, is a sign of our changing climate, okay? You have to have several years of these types of changes though, remember, to build to climate. So lots of times when we start to understand climate and climate change, it's talking to our parents and grandparents about what it was like when they were our age, how many snow days they had, when was the first snow, how much snow was on the ground for how long, when did it get really hot, how often did it get really hot, and then you can start to see these comparisons that have happened really within the last 65 to 70 years, which is very interesting when it comes to climate change. We're finally getting to the point where we can have experienced this ourselves, or definitely within the kind of human generational time frame. That's another thing that I want you to consider is that climate change is happening at a rate that we can actually observe these changes. It's happening fast enough that we can have the data and the experiences to back up that climate change is happening. Yeah, Elena.
I think a common misconception is that people don't think that the extremes can happen on both sides. Because
Mhm.
if you're
Good.
talking to someone about climate change, they're like, with how cold it was last week, but they don't understand that that's part of it.
They think it's
Climate
global
change.
warming versus.
Good.
That's because what it used to be global warming.
Good, and that's something that we'll consider, that part of climate change is global warming. But not all of climate change is warming. It is a change and shift in all of these types of patterns.
So it isn't just, well, this climate change is supposed to be.
No.
Yes, we
Is
are.
this a quiz?
Series, but that does not mean that every day will be hotter.
This is not a pop quiz. is this?
No, this is not a pop quiz.
I don't do pop quizzes.
Climate change.
Okay.
Okay.
wants to know if it affects its grade.
It does not, well, it does affect your grade because you're in class to participate, and that gives you 0.5 participation points, which adds up into your grade at the end of the semester.
Happy
So,
to participate.
but it does not matter if you get these questions right or wrong as to how many of those 0.5 points you get. So you get 0.5 points to write your name at the top. First and foremost, write your name at the top. Okay. All right, before we start talking about more of the details and facts about climate change, I want you to test your knowledge about where you are, and so that we can confront some of these misconceptions and misunderstandings both right now and then as we continue throughout these lectures. So take your time, answer the 11 questions. You're welcome to chat with a person around you if you want to confer about an answer. But I do want you to try to do them quickly. You know, what is your gut response and answer here, okay? It's fine if you get them wrong.
I'm working, just
It just
like
fails.
gravity.
I was sure it was the battery. I was like, all you need to do is.
Well,
It was clearly the battery.
Well,
And then
I
there's other
actually
things.
opened up the back.
Yeah.
And it was loose against the connections where the battery is, so it wasn't activating the actual, like,
Yes.
ears.
For question number 2, it says if you remove the natural greenhouse effects,
Yep.
so is that including everything that we've put into it, or that's just the stuff that's supposed to be?
The stuff that's there naturally. So there's water vapor, there's naturally methane, there's naturally carbon
Yeah, I just didn't
dioxide.
know because
Yep.
with, if you take away everything you put up there with it, it would drop significantly
Yeah.
more than just what is supposed to be there.
So one thing to keep in mind is that the Earth has only warmed 1.8 degrees Celsius so far. And so that's actually, you know, it's a small change. It's measurable now, but it's really a small change. So, you know, we're talking about like 2 degrees Fahrenheit
But if you take
with everything we put up there.
If you take it
And
all.
all away, what would happen to temperature?
Now that just complicated things for me. I'm overthinking
okay,
it
so
now.
like-
Well, this doesn't count, so it's fine. It's a learning
Alright.
tool.
Okay, then you can see. Gonna be a little hard for the true or false.
I was gonna say, but there's
But
not a C for D.
you can pick C for all the other
Only
ones.
one, maybe.
True, false.
I don't know.
Yeah, they did like we did our post assessments in high school. I don't know.
I don't know.
That was always so infuriating because I'm like, why give students the option? Make them pick one.
Well, it's a pre-assessment.
For the
thing.
pre,
The pre-assessment makes.
it made sense.
Right, yeah.
Post-assessment,
Post-
no.
Okay, shh, okay, we're getting off topic. We have to stay on target. Okay, let's talk about our answers, see where you were, your current state of knowledge. All right, the greenhouse effect is caused by A, B, C, or D. Caleb? It is B. Greenhouse gases in the lower atmosphere absorb radiation from the Earth's surface, okay, and they prevent it from escaping out into space, and that keeps it then next to the Earth. That means that the more greenhouse gases there are, the more that re-emitted heat essentially stays. So it's B on number one. If you remove the Earth's atmosphere's natural greenhouse effect, Earth's temperature would be
D.
50 to 60
Whoa.
degrees Fahrenheit cooler.
I am failing. Okay.
Life on Earth is possible to some extent because of the greenhouse gases that are in our atmosphere. They help to warm and moderate our climate and our temperature in particular. Changing them then affects those same things, temperature, which then affects precipitation. Okay, which of these natural events affects the climate, A, B, C, or D? D, that's right. We'll talk about all these in a second. You're like, how is that possible? That is what we're here to talk about today. Okay. All right, the 6 hottest years on record occurred during the last A, B, or C? A. A, all right. Last 10 years, our 6 hottest years on record have occurred during the last 10 years.
They actually are all the right answer because.
So you could say on record, and we're talking about kind of human meteorological records, which go back about 350 years. Okay, average global temperature rises, will precipitation decrease, not change, or increase? Increase, okay? The warmer it is, the more evaporation will happen, right? Which means that you'll end up with more precipitation as a result.
I'm super grateful this isn't a quiz.
I know, right?
Compared to other greenhouse gases, this gas is the most effective at enhancing global warming. Carbon dioxide, nitrous oxide, methane, or fluorinated hydrocarbon.
Carbon.
No, D.
What?
The fluorinated hydrocarbon.
I was like, CO2.
How do you make fluorinated?
What? In a lab.
Oh my God, I thought that was the one I was gonna get.
They're,
Really gonna go back.
they're not natural. And it turns out that a single, this is on a molecule by molecule basis. A single molecule of something like a fluorinated hydrocarbon, a CFC, absorbs more solar radiation, or more re-emitted solar radiation, and holds it in the atmosphere longer than a single molecule of methane or carbon dioxide.
Where's the fluorinated hydrocarbon?
Enhances global warming.
Yeah. So we use them as lubricants. We use them as cooling agents. We use them as precursors to other compounds that we use in industry and commercial products. So if they get into the atmosphere, when those uses of them break down, or when they're used in a manufacturing process, they get aerosolized and then they go up the smokestack up into the atmosphere. And so it takes many, many years of use for them to build up to measurable concentrations and to have an effect on global warming. But they do.
How long is it?
So the fluorinated hydrocarbons are particularly long-lived and persistent. So again, because a single molecule retains a lot of heat and stays for a long time in the atmosphere, they really contribute a lot to overall global warming. All right, okay. Some kinds of pollution can act to cool the planet. True or false?
True.
True. That is true.
Yes.
Okay, that is true. All right, the Earth has been warmer in the past than it is today. Number 8, true or false?
True.
True. Has been. Which of these countries has the highest per capita carbon dioxide emissions?
China.
China. Oh, no, that
America?
that would be us.
Dang it.
It's always China.
Always us.
We always blame China
Always
though.
us. The U.S. Always us.
I thought they're stupid coal burn.
So we emit fewer we emit less carbon dioxide today than China does. But over our history of it, we produce more per capita. And so China is relatively recently industrialized, and I think they're responsible for like 3%, 4% of overall global warming, like climate change that's happened. But the U.S.'s emission of carbon dioxide over history has been so much greater per person that we're responsible for like 23% of global warming.
So this is over.
Yeah. Yeah, we're thinking like a little bit of like history. Like today, we're probably like less.
We're not.
But the other thing to remember is that even though China emits a ton, right? They're like here, they have 1 billion people. Okay?
So per
And
capita,
so like per capita, it's not a lot. We still do a ton, it's like right here, but there's only 330 million of us. Okay, so per person, we do a lot. It makes more sense. I would say if we do, you can think about that China might be doing like 100, you would say. Okay, but they've got 1 billion down here on the bottom. All right, even if we only did like 50, there's only 330 million of us. Okay.
We only have 330 million people in the United States.
Yeah.
I didn't answer something.
We act like there's more of us.
Mhm.
That's a big attitude. And I'm okay with that. All right, which of the following activities contributes the most to carbon dioxide emissions globally? Traditionally it's been D, energy and electricity generation. Today, in the last couple of years, 2017, 2018, it's almost entirely equal to done by transportation. So B or D would be fine. If I were to ask you a question similar to this on an exam, I would put those two together and be like, or is it A and B? And you'd be like, yeah, it is A and B together. D, transport and electricity. Okay, last one. How do scientists collect evidence about climate change? D, all of the above.
I put these two, I said it, but.
Okay.
I got 4.
You can pass your little pop quizzes to the front of the classroom. I'll return them to you. I'll give them. I will. I'll give them back to you. These are great examples of possible exam questions. Like now that we'll continue to talk about the correct answers throughout the next couple classes. They're going to be a good study guide for you. I'll return them to you on Thursday so you can use them in that. Okay. The next topic that I want us to look at are the possible causes of climate change, and then we're going to look at the evidence for climate change. Okay. In general, when we talk about climate and climate forcing and making climate models, we consider these 5 things that are in red as the dominant factors that can influence climate and that can shift things like temperature and precipitation and wind patterns and storm frequency, both averages and ranges for them over long time periods, over big geographic areas, okay? And it all comes down to solar radiation, how much of it we receive, how much of it we retain, which is why I have this picture of the solar flare here. It's all driven by solar energy, which again is one of the fundamental concepts in environmental science, which really fits well with the class in general, of course. The first one that I want you to kind of fix in your mind is that these changes in how much solar radiation we receive and retain are the foundation for this. We can modify how much is received in a variety of different ways, and we can modify how much is retained in a variety of different ways too. A lot of it comes back to how close we are to the sun at any given point in time, okay? And that's where Earth's orbit and solar output are important, okay? The more energy and emission that the sun puts out, the warmer we will be, okay? The emission from the sun has been very, very constant towards the Earth for the last 2.5, 3 billion years, okay? Solar output is not something that's varying on a scale of which we experience climate change today. Yeah.
One thing I was reading when I was working at climate change like a year and a half ago.
Yeah.
They were talking about how a lot of people were still thinking that part of global warming or climate change that was happening today was because of a few solar flares that happened.
I would say possibly. I think that if we had consistent solar flares time and time again, we would be changing the amount of radiation we receive from the sun. It takes some period of time for those radiations of these solar particles to hit the Earth, and so there might be some lag between when they happen and when they hit us. It does not take long for light from the sun to travel to the Earth, and so there's not a change in that amount of heat that we're receiving. I would say that the periodicity of these solar flares and the intensity of solar flares that we're experiencing in the last 100 years has been such that it is not likely causing climate change today. Has it caused climate change in the past? Perhaps, at points when the sun was more active or much less active. But the activity of the sun, my understanding of it of right now is that we're actually experiencing relatively few of these solar flare-ups. And so it should actually be a period of possible cooling rather than warming. And that's definitely what we experienced in the first half of the 1900s, was a period of cooling. Okay, the other thing that contributes to this is our orbit around the sun. You know that when it's summer and we're tilted towards the sun, right, it's warmer. Okay, same thing happens. Our orbit varies in its elliptical path around the sun. When it's more circular, we spend more time close to the sun, it gets warmer. The tilt of our axis shifts just a little bit. And so when we're very tilted towards the sun, we tend to receive more radiation, we tend to heat up. As that swings back more towards vertical, we're talking about like 23.5 degrees tilt versus 21.5 degrees tilt, okay, vertical to the sun. Then it gets cooler as we shift away from it. Those types of things do influence climate, and we can see that when we are closer to the sun and these things align, it does heat up on Earth. Okay, we can see that in our last 100,000 of years of climate record. That is not happening right now. We are not in a period where our orbit and our tilt are causing us to be warmer than we have been at other times. Okay, and those cycles of shifting, changing climate and temperature due to changes in our relationship to the sun happen on 100,000 year to 400,000 year time scales. Okay, they take a really long time to gradually shift and change, not this 150, 250 years that we're experiencing climate change today. Other things that can, of course, affect how much solar radiation we receive and its retention are things like thermohaline circulation in the oceans and the distribution of the continents across the surface of the planet. As Pangea, this big supercontinent, broke up, we altered ocean circulation patterns. That shifted where we received solar radiation and how it got moved across the globe. That shifted climate patterns. Okay, it used to be this huge tropical swamp, these shallow seas. Now we have dry land with the climate that we have today. Okay. Again, those things are constantly changing over time. Yes, ocean circulation is changing. Yes, the tectonic plates are moving the continent slowly over time. Not at the same magnitude of change that we're experiencing climate change today.
Do you think that we'll become one big continent again?
Yeah, so it's super cool. 250 million years from now, we'll be a supercontinent again. All right. It's going to be predominantly in the northern hemisphere. I'd have to go back to the Cincinnati Museum Center to check out exactly how this big supercontinent is located, but they have at the Cincinnati Museum Center, they have one of those Earths on a sphere, and you can do Pangea to the Laurasia continents to today's tectonic plate conformation, and then they'll do it like 65 million years to 250 million years in the future, and it'll be this supercontinent again. So what's that?
Talk about war. Everyone's going to be bordering each other.
I know. It's all going to be shared again. There will be these different countries. Okay. The other thing, of course, that can affect climate is cloud cover. The more clouds we have, the more solar radiation gets reflected away, the less hits the Earth, the cooler we tend to be. All types of things affect cloud cover. Okay. Organisms can affect cloud cover. Volcanoes can affect cloud cover. Ocean circulation can affect cloud cover. Greenhouse gas concentrations contribute to cloud cover shifts and changes, okay? Cloud cover, though, again, is something that we tend to think of in terms of weather patterns and somewhat localized. And again, cloud cover is changing today. The cause of it, though, is not changing ocean circulation or plate tectonics or changing radiation we're receiving or where we are in our relation to the sun or volcanoes. Changing cloud cover today is due to global warming, which is caused by changes in greenhouse gas concentrations. Okay, volcanoes can cause climate change. You have lots and lots of volcanoes. They will spew out a couple different things. They'll add greenhouse gases to the atmosphere, and they'll add soot to the atmosphere. And those two things have competing impacts on climate. The added greenhouse gases tend to warm us up, but the added soot and ash in the atmosphere tend to reflect incoming sunlight and cool us down. And so big super volcano explosions like we had probably at the end of the Permian changed climate afterwards. We're actually in a lull of volcanic activity here on Earth today. And so volcanoes are not causing the climate change we're experiencing right now. Yeah.
What's the time period until Yellowstone's supposed to blow again? Do you know what that is? I remember learning about it.
I feel like it's the next 100,000 years.
So what, like,
Probably not, but it's an unstable region. And it is one of these large volcanic geothermal regions that we consider stable today because it doesn't have active volcanic activity. But those hot springs that we associate with Yellowstone National Park are a sign of underground rumblings and seismic activity. And eventually it will pop in as it has done in the past. Yeah.
Do you think all humankind will disappear like the dinosaurs did?
I don't know.
Deep
And
question.
We're too stellar.
we're too stubborn. My personal opinion, I think is something that I think it can go lots of different ways. And I'm very hopeful about our future as a species. Having said that, most species that have lived over the course of Earth history have existed for a certain period of time and then they go extinct. Like extinction is a natural process, just as the rise of new species is a process. And so it's almost more interesting to think of what species will we become in the future? What are we going to evolve into?
I hope it becomes
I don't want to be a dinosaur.
Dinosaurs.
Yeah, I kind of like humans. Okay, the next thing on the list is land albedo, and this is what we call reflectivity. So ice has a very high reflectivity for the amount of solar radiation it reflects. And so if we have lots of ice on the surface of the Earth, we tend to be cooler because the incoming solar radiation gets reflected and bounces away rather than being absorbed. So white paper, white concrete reflects a ton of incoming solar radiation. The dark surfaces, soil, open water, black asphalt, absorb a tremendous amount of solar radiation rather than reflecting it. So the more that we urbanize, the more that we agriculturally have available to us, the less ice cover that we have, the more incoming solar radiation we retain, and the warmer we'll be as a planet. Land albedo is shifting right now. We're seeing places where we're losing reflectivity, but in other places, we're seeing desertification. And deserts and sands are another big area where reflectivity is high. And so it actually evens out across the globe between expanding deserts and losing of ice sheets and urbanization. Land reflectivity is going to be about the same as it is now in the future and has been in the past. Yeah.
so is there something we can do to not use asphalt, besides the
Concrete.
Yes. You can use permeable surfaces and permeable concrete.
Just way more expensive.
It's more expensive, and it is not what is the tradition to do. Like, I get so infuriated when I come into my neighborhood and they repave the road surface with black asphalt, and I'm like, oh my God, why are we doing this? It's so bad for the environment in a few different ways. But it's what we all expect to happen when they repair the roadway. Okay, we expect them to black asphalt over it and make it a nice smooth surface. Okay, our expectation of what we want to happen has to change too. It depends on the wear and tear on the roadway. It depends a lot on weather conditions too. Like we had a particularly like up and down freeze thaw cycle this past winter, and it was terrible for the roadways. They were salting all the time. These big trucks that were running over them, and this time of expansion contraction that the roadways were undergoing got all these really bad potholes this last winter. Okay, next thing is that the biosphere, living organisms, can influence climate. You have lots and lots and lots and lots of plants. You'll suck in a tremendous amount of carbon dioxide. You'll actually reduce greenhouse gas concentrations and you'll cool the earth. This happened when we had the expansion of land flowering plants that first happened in the grassland region about 150 million years ago. And all these plants that suddenly appeared, they sucked in carbon dioxide to cool down the planet, okay? You can think of us as part of the biosphere, like we're changing greenhouse gas concentrations today. We're affecting land reflectivity. We're not yet interfering with volcanism or the Earth's orbit around the sun. We're part of the biosphere. We are part of the climate change that we're experiencing today. Okay, but what it looks like that's happening today are changing greenhouse gas concentrations. This is one of the natural things that can happen. We can have volcanoes that enhance greenhouse gas concentrations. We can have the biosphere that affects greenhouse gas concentrations one way or another. This is the only one of these factors that can affect global climate that is measurably changing at the same rate and magnitude that we see climate change happening today. And so all these are possible causes of climate change today. Only greenhouse gas concentrations are the one that fit in terms of explaining climate change today. Then the question becomes, why are greenhouse gas concentrations changing? Okay, well, it has to do with the biosphere, particularly us as a species on the Earth. That's the thing that has shifted. Okay, so again, greenhouse gas abundance changes. The thicker this blanket, okay, which is the top little image, the thicker the blanket of greenhouse gases that we have around the Earth, the warmer we will be, okay, the brighter yellow color. If we thin down this greenhouse gas layer, we'll be cooler. Okay, that's the general correlation, and you guys had a pretty good understanding of that from the little quiz that you took at the beginning of class. Okay. Everybody's comfortable there. Okay, the more greenhouse gases, we retain more heat, and we'll be warmer as a planet. Yeah, Caleb.
So there's some researchers that are working on creating a machine that builds the atmospheres.
Cool.
Is that something that could remove?
Potentially. One of the things that's been hypothesized for the Earth is that as we build up greenhouse gas concentrations, if we can reflect away more incoming solar radiation, then less will hit the surface and less will be retained. And so these things of like big solar mirrors or sunshades that we could deploy could be helpful in changing the actual amount of solar radiation we receive. And that would help us with changing greenhouse gas concentrations. Those same types of things are considered in the terraforming of places like Mars or Venus, where again, you go in and in this case with a mirror or a sun shield or an atmospheric builder, you want to build up the atmosphere of Mars so that it's breathable and it actually retains enough heat that it would be of a temperature, both range and moderation that would be good for humans and the things that we like to have with us to be there.
So you're just going to make an atmosphere instead of driving cars and plants can make oxygen.
Exactly. Like the terraforming of Mars, like the concept and the understanding of what needs to happen is there. The practice and the time scale of how to have it happen quickly enough to be helpful to us or to happen on a time frame that humans again would be around as a species is the catch point, I think. Because those things take millions to billions of years. And again, we want this to happen in a human time frame of a couple to maybe 10 human generations. Okay, so how does this thing with the greenhouse gases work? Okay, more of them make us warmer. What is the actual physics of this process? And it is straight physics, okay, with a little bit of chemistry thrown in. What happens is that we have sunlight that's coming in. Hits the surface of the Earth. Some of it's reflected, some of it is absorbed, and then that heat gets re-radiated out. The greenhouse gases, each molecule of greenhouse gas will absorb some of that re-emitted heat and keep it in the atmosphere with us. Okay. Again, this is something that has been vital to keeping our current planet at the temperature of what it's supposed to be. Okay, we've always had greenhouse gases in our atmosphere, predominantly water vapor and carbon dioxide, that have helped to warm the Earth in the first place, that keep us with liquid water. Okay, keep us from freezing into a total ice ball each night. Okay, but we're also starting to the point where changing these greenhouse gas concentrations has happened to a point today that we're actually retaining a lot more heat than we have been in the past. Okay? And that then affects climate, right? And it does so to the side of global warming in this case because we're building up greenhouse gases. We're retaining more heat than we have in the past. It's called a greenhouse gas because it acts just like the glass roof on a greenhouse to keep in incoming heat and solar radiation. Remember, in a greenhouse, it's warmer inside. You can grow tropical plants in the middle of Antarctica if you wanted to, right? Like that's the point of the greenhouse. These gases act as the same thing. They trap heat next to Earth on a global scale rather than a little greenhouse. everybody cool?
The slide is not.
Okay, all right. Different greenhouse gases, again, as we looked at our little quiz, have different warming potentials. A molecule of fluorinated hydrocarbons, brominated hydrocarbons, have the greatest warming potential. What our textbook focuses on are carbon dioxide, nitrous oxide, the N2O that we encountered before in air pollution, and methane. Okay. The warming potential we set for a molecule that's in a greenhouse gas molecule to be constant compared to a molecule of carbon dioxide. So we say that a molecule of carbon dioxide has a warming potential of 1. Okay? A molecule of methane has 25 times more warming potential. And a single molecule of nitrous oxide has 300 times more warming potential. Yeah. The fluorinated hydrocarbons, their warming potential is on the order of 5,000 to 10,000 times that of a single molecule of carbon dioxide, which is why, even though there's fewer of them, they have a greater impact to some extent. Okay. The thing to keep in mind, though, is this idea of concentration. Okay, each molecule of those fluorinated hydrocarbons does a lot, but there are relatively few of them. Okay, each molecule of carbon dioxide doesn't do a lot, but there's the most of them out there, okay? And that's the thing that's changing the fastest when we look at these greenhouse gas concentrations, okay? And so that also plays into this idea of atmospheric lifetime. How long does each of these molecules last up in the atmosphere affects its overall warming potential, okay? Methane's kind of in the middle, but it doesn't last for like 12 years before it gets broken apart. A molecule of carbon dioxide and a molecule of nitrous oxide are going to be up in the atmosphere for on the order of 100 years before they break apart. So each molecule of these things that we emit is going to be up there acting as a greenhouse gas for a certain period of time. The other big problem with those fluorinated hydrocarbons is that they last for a really long time in the upper atmosphere. They're on that 300 to 500 year time scale for how long each one of those molecules lasts. Okay. So there's a whole bunch of stuff here that we consider a greenhouse gas, but we tend to focus on, and with reason, on the carbon dioxide because there's a lot of it, and it tends to last for a good period of time. Okay, so CO2, what is it? It's a colorless, odorless gas. My kids are always like, wait, but it's purple, because on Neil deGrasse Tyson's most recent Netflix series, the last episode of it, they talk about carbon dioxide and global climate change, and they color all the tailpipe emissions purple, so you can see it. I'm like, oh, Neil deGrasse Tyson. So much going on. You can't see it, which also makes it very difficult, both with methane and nitrous oxide and CO2 and these hydrocarbons, to recognize when they're being emitted. It's much harder than soot or ash that goes up a smokestack to recognize the magnitude of the change that we're making. Okay. Anything that we burn essentially produces CO2 as a byproduct, particularly if it's organic matter that we're burning. So fossil fuels, wood burning, trash burning, all of that emits some carbon dioxide. It also comes from a variety of natural sources. When you breathe out carbon dioxide. When we have weathering and erosion of carbonate-based compounds and minerals, that also releases carbon dioxide both into the atmosphere as well as into the water. And of course, I mentioned volcanoes when we talked about sources of climate change. Part of what they emit when they spew out gases is a bunch of carbon dioxide, as well as some of these important greenhouse gases. Okay. The big reason we're concerned about carbon dioxide is not because it interacts to cause respiratory illness or asthma in anybody or organisms. It doesn't change the pH too much of the atmosphere, although we're going to see it does have an effect on the oceans, is because it acts as a greenhouse gas and it helps to trap in the atmosphere. Okay. Here in the United States, the most recent data that we have from the EPA is our 2016 carbon dioxide emissions, and we see again that electricity generation and transportation are the major sources of CO2 emissions and greenhouse gases in general, considering the other types of greenhouse gases that we have here. Yeah.
So is this like the United States debt, and it's just gonna, like, no matter how long we go, we're just gonna keep adding greenhouse gases, or will it eventually like level off?
Yeah, so if we reduce our CO2 emissions from what they are today, both in the US and globally, we'll actually start to see a decline in greenhouse gas emissions. It's gonna take 150 years, because they last for a certain period of time in the atmosphere. You know, when I drove my car down here from Mason to Claremont today, I emitted a certain amount of carbon dioxide. That's gonna be in the atmosphere the next 100 years. That's another thing to consider when we talk about climate change, is that for every year that we continue to produce more of these greenhouse gases, we're committing ourselves to another 25 to 50 years worth of warming. So yes, if we stop emitting them, eventually the greenhouse gas concentration will come down again. It's just gonna take time.
I don't mean to stop anything. I don't see the use of greenhouse gases going down enough where we stop, but like, is there a point at which if we were to stay where we are, where no matter how much we put out, this is how much is in the atmosphere?
Yes, so if we were to level off our CO2 emissions at what they are today, in about 150 years, we would stabilize with a stable climate again. And we would have a climate that was then, and it would not be changing any longer. Yes. Okay, if we look at CO2 concentrations in the atmosphere for the last 400,000 years, this is largely based on ice core data, we can see that CO2 concentrations measured in parts per million in the atmosphere have gone up and down over time. We can see some of those kind of 100,000 year cycles of changes and variability. It does go up and down a lot. You know, it goes from 300 all the way down to 180, from, 375,000 years ago to 250,000 years ago. That's the same kind of change that we're experiencing today, where we've gone from like 280 all the way up to 400. Okay. The magnitude of change that we're experiencing in CO2 concentrations is pretty phenomenal in the case of what we've experienced in the last 400,000 years. Okay. The other thing that I really want you to recognize is that the time period of change is very, very short. Okay. I talked about that 375 or 325 to 250,000 years ago. Okay. That 120 part per million change in carbon dioxide concentration happened over the course of almost 100,000 years, 75,000 years. We've done the same amount of change in the last 175 years, okay? And that's the concerning part of climate change today, again, is that the rate at which we're changing is so fast to compare to when these things have changed naturally in the past, that we don't know what will happen. We're very unsure of how species will adapt to this type of change. All right. If we look at CO2 concentrations in the recent future, when we've had very good methods for measuring atmospheric concentrations of modern day CO2 changes, we get data like this, which is known as the Keeling curve, named after the scientist that developed the method of measuring atmospheric CO2 concentrations. This starts in about 1958, and it goes through, this is the March 2019 data, it's the last data that we see here. How have CO2 concentrations changed in modern times? Yeah, they've been almost an exponential increase. Sometimes we refer to this almost as like a hockey stick graph, where it's constant for the last 100,000 years, and then it just shoots up, exponentially growing CO2 emissions. Again, the question that becomes, what is changing CO2 concentrations in the atmosphere? We know that CO2 concentrations and greenhouse gas concentrations can affect climate. We can start to link these two things. Climate change is caused by CO2 emissions. What then is causing CO2 to change in the atmosphere? Okay, not changing amounts of plants, not changing volcanism, it's not changing thermohaline circulation. Okay, it's us, all right, and our burning of fossil fuels for transportation and electricity. Yeah, only population has something to do with that too. To some degree, but again, we talk about respiration as a source of CO2 emissions. The plants around us are in balance to some extent to be able to take up the amount of CO2 that more people emit. And so, our ability to push that dial is really limited in comparison to burning fossil fuels. Willow, and then,
So if we cut down, like, say, how much CO2 we created, would the plants still be able to survive since they're getting used to like having more CO2? So say we cut out what we're.
oh yeah,
producing right
they'll be
now,
fine.
It was just like the respiratory basically.
They'll be fine. Some species are predicted to do really well with enhanced CO2 emissions, and some species will do worse with less CO2 emissions. But in general, plants are kind of glad we're emitting a lot of carbon dioxide. It's good for them. The difficulty for plants is the changing temperature and precipitation that comes along with altering greenhouse gas concentrations. Taylor?
So one of the things is, obviously, if the population goes down, there's less carbon dioxide that's emitted. And one of the things that I learned in my previous environmental science class is how close we are to what they believe the population max is for the human population.
Yeah.
And the max capacity that the earth can handle. And the problem was humans have eliminated the things that can, level off the population like it's supposed to.
Yeah.
There was the bubonic plague and all these sort of diseases that was, it's not, you don't want to think like, oh, it's a good thing that all these people died.
Oh, yeah.
But like for the earth, it happened because there were too many people. It spread really easily because there were so many people, and so a lot of people died. But that doesn't happen anymore. So.
Exactly. We've eliminated the things that used to control human population. Disease, predation. The only thing we have left is our intra-species competition, our competition with one another for resources. Like this whole idea of like war. Okay. So like one of my students last semester was like, we should have more bombs, as a solution. And I was like, no, that's probably not it. Okay. But it is that idea that we have eliminated our natural controls on human population size. And that's good. Like, we like us. Okay. Like, our quality of life is much better than it has been in the past. But it has come at this consequence. And this is some, aspects of this are that, hey, the earth is re-exerting its control over human population by changing climate, by eliminating food resources, by rising sea levels, by enhancing storm activity. I'm kind of like, maybe, I'd like to think that we can respond to that as well and shift it back. Yeah, Emily.
Why haven't people taken this seriously as they took the hole in the ozone layer? Because it seems like they immediately took action to try and fix that.
Good question. So what is different about greenhouse gas concentrations changing and climate change versus the CFCs in the ozone hole?
I think people hear hole, not to oversimplify, but I mean, if there's a hole, then it's broken.
Yep.
And that's something that needs to be fixed. And maybe they just don't think deep enough about the greenhouse gases. Also, I think the role it played in skin cancer and direct consequence to the individual made it more imperative.
Good. Both of those things definitely play a role in our response to climate change. Like we used to talk about global warming and then people would be like, but it gets cold in the winter and it snows. And then we're like, maybe we should talk about climate change. So now everything we talk about is about climate change. Caleb.
I think one of the big reasons that got more attention was the idea that with the hole in the ozone, if the hole continued to grow, that would really, that would kill.
It was like it would affect us.
Yeah, it like eventually, the hole started in Antarctica, but if we kept producing these things and they started to create holes in other areas, it would kill a lot of people.
Yeah, that kind of goes into what I was gonna say, because I was gonna say, people care more if it's on their lifespan, so if it's on the lifespan, people actually take into effect more, and I think with climate change, it's not gonna affect us right now as badly as it would affect people in the future.
Good. This idea again of direct individual consequences. You'll get skin cancer because of the ozone hole expanding. I'm gonna take action today by what hairspray I buy, okay? Versus climate change, in 50 years, it might affect food production so that I'd rather live in Canada. Okay, I'm gonna drive today again, okay? We're very good at short-term consequences and risk evaluation. Like that's what we're designed for. Lion, I think I'll run the other direction, okay? Pride of lions over there, I can hear them roaring. I'm okay, all right? That's our evolutionary history. It plays into our response to climate change, and we can't forget that. The way that people start to begin to respond to climate change is when it starts to directly impact them. That's when I asked you about how climate change impacted you at the start of class today. You could identify things that had changed in your lifetime, but they were not really impacting the way we live our life in Ohio, okay? For people who live in Florida, Louisiana, these Pacific islands like Samoa and Madagascar and Sri Lanka, like they're experiencing climate change on a day-to-day basis. They're losing land to sea level rise and flooding. And they are much more invested in responding to climate change than we are here in the United States, in Midwestern United States, where climate change is not really changing our day-to-day life, impacting it. Yeah.
Lifespan kind of idea kind of close to like about everything we talked about. Good, like water pollution, like plastics, and because I feel like it kind of shows everything.
What I want you to recognize from our next lectures in class is that the impacts of climate change will be felt like us in our lifetimes, okay? My kids are gonna have a different world based upon what we have done in the last 25 years and the choices we make in the next 25 years. Yeah.
This kind of just like lifespan impact hasn't just affected like climate change. Like way back in America's history, they postponed dealing with slavery. They were thinking, somebody else can get to it.
Right,
It's
again,
human nature.
we have this human nature problem about dealing with these kinds of
Selfish.
problems. The other big difference between ozone hole and CFC production and CO2, greenhouse gas production, is that with CFCs, we had a very particular sector of a few types of industry that were making them. Greenhouse gas production affects all of us in our daily lives in multiple ways. And that makes it very much harder to respond to in a both responsible as well as effective fashion.
I think one of the biggest things as well is kind of one of those things where the global warming and climate change isn't necessarily going to affect the people that it needs to affect enough to where we'll do something, right? We talk about first world problems all the time, and in our society, it gets a little warmer outside, and in America, we'll find some way to keep going. Like, it's not like
We just turn up the air conditioner.
yeah, the
Oh,
air
God, yeah.
conditioning goes on, we find some new ways to disperse water and stuff to make sure the plants survive,
Yeah.
and we don't really feel it that much.
Right.
But the places that are gonna feel it are the places that don't have that stuff, they don't have the resources to do anything about it.
Right, good. The cause of the problem are not the people who are feeling the effects. There's a dissonance between those people who are most impacted by climate change and the people who are responsible for climate change. Our ability to deal with it is very different from, again, somebody in Sri Lanka or Mozambique or what were those countries in Africa that just got hit by that cyclone? And I was like, dude, that sounds terrible. Okay. Again, the other thing I want you to recognize about climate change is that the impacts that are being and will be felt by it affect most of the people on the planet. Okay. Most of the people on the planet live in places that are going to be much more heavily impacted by climate change than the United States. Okay? They're eventually going to get pissed. Okay? They're eventually going to say, stop. Okay? And guess what? They're already saying stop, and we're not listening. Okay? And so their next course of action could be quite frightening. So consider that. We're going to pick up with good pieces of evidence of climate change and kind of predictions, consequences of climate change on Thursday. I'm going to put up some readings for you on Blackboard about current evidence of climate change. Take a look at them. I'm going to link the fourth U.S. assessment of climate change for you as well. It's a big document. There's lots of information about it, but it really reiterates a lot of the messages and the data that we're going to be looking at in class. Okay, go forth and do well. I will see you.
Where did you get that shirt?
Target.
Really? Yeah.